Hello everybody, this is Mrs. Snook with section 7.3, More Multiplication Properties of Exponents. And what we're going to do today is raise a power to a power, so it might look something like this. 3 squared, and then raise that whole thing to the 4th. We can also do a product of a power. So last time we learned that if I multiply a base by another one of the same base, so like 3 to the 2 times 3 to the 4. Okay. Since the base was the same, you would add the exponents and you would get 3 to the 6. Today we're going to figure out what happens if we do 3 times 2 and raise that whole thing to, say, the 6th. These are the two kinds of problems we're going to do today. Our first problem says that the radius of a bubble made by the bubble machine on the right is 2.5 times as large as the radius of a bubble made by the bubble machine on the left. So if the radius on the left is x, then the radius on the right is going to be 2.5 times x, or 2.5x. And then it says, what is the volume of a bubble made by the machine on the right, with the bigger radius? And we're told that the volume is 4/3 times pi times r cubed. So let's do the volume of a bubble on the machine on the left. Volume is 4/3 times pi times r cubed. That's our formula. And we're going to say that our radius is x inches. So volume would be 4/3 pi x cubed. Okay. Now I don't know what x is, so I'm just going to leave it as x cubed. Now let's look at the bubble machine on the right. Its radius is 2.5 times the size of the other radius. So its volume is 4/3 times pi. But instead of putting in r cubed or x cubed, I'm going to put in 2.5x cubed. Okay, so let's see if we can figure this out. I have volume is 4/3 pi. Now 2.5x cubed is 2.5 times x times 2.5 times x times 2.5 times x. So I get 4/3 pi. I have x times x times x, which is x cubed. And then I have a 2.5 times 2.5 times 2.5. And that's a 2.5 cubed, which equals 15.625. So now take a look. The bubble machine on the left, the volume of that bubble is 4/3 pi r cubed. Here we have that same 4/3 pi r cubed. So the bubble machine on the right is going to make bubbles that are 15.625 times the volume of the other bubbles. Let's see if we can find some shorter, easier ways to do this instead of multiplying our 2.5x by itself 3 times. Just so happens we have a power, a property of raising a power to a power. And what you're going to do when you raise a power to a power is you're going to multiply those two powers together. And that's going to work as a shortcut. So if I was doing 5 to the 4 to the 2, that's the same thing as 5 to the 4 times 5 to the 4. Because what I've done is I've just squared that 5 to the 4. And then remember from last time, just add your exponents together and you get 5 to the 8. Now that 8 is the same thing as 2 times 4. So if you multiply the exponents, that'll work. Let's try it on another one. Let's try m cubed to the 5th. Now I'm going to take that m cubed and I'm going to raise it to the 5th. So I'm going to multiply it by itself 5 times. So here's m cubed Here's m cubed. Here's the third one, the fourth one, and the fifth one. Whoops, I wrote 5. Add your exponents together. 3 plus 3 is 6, plus another 3 is 9, plus 3 is 12, plus another 3 is 15. This is m to the 15. Sure enough, right there, 3 times 5 is 15. So as a shortcut, we're just going to multiply our exponents together. All right, so let's do some problems. We've got the first one is n to the 4th raised to the 7. So that's going to be n, multiply our exponents together, 4 times 7, which gives you n to the 28. Example 2, this time I've got x to the 2/3 raised to the 1/2. So multiply your exponents together. So this is going to be x to the 2/3 times 1/2. And those 2's, when I multiply them, the 2's cancel. So I'm going to get x to the 1/3. Here's our last one. Try this one on your own. Do p to the 5th to the 4th. Did you multiply your exponents together? If you did, you should get p to the 20th. Now let's try it where we have only variables here. And look, I have some negative exponents too. So our first one, we have y cubed, and we're going to multiply that by y to the 5/2, which is being raised to the -2. So I'm going to multiply those exponents together. Those 2's cancel. So I'm going to get y to the 3 times y to the -5. And just like last time, let's add our exponents together, and then we'll see if we need to move anything downstairs. So I get y to the -2. Now I still have a negative exponent, so I'm going to have to move it downstairs. And I get 1 over y squared. All right, next one, I have x squared, x to the 2, which is x squared, times x to the 6 raised to the -4. So x squared, that just stays as it is. Now I've got x to the 6 to the -4, so I'm going to multiply those exponents together, and I get x to the -24. Now I'm just multiplying the same base, so I get x to the -22. Move that downstairs, 1 over x to the 22. Here's our last one. We have w to the -2. It looks like I'm going to have to move that downstairs, but let's go ahead and simplify w to the 5/3 raised to the 3, because maybe I can skip a step. So take your 5/3, multiply it by 3. Those 3's canceled, so I'm left with w to the 5. And that becomes w cubed, so I don't have to move anybody downstairs. All right, now let's raise the product to a power. So we've raised a power to a power. Let's see what happens if I take a product of two numbers, so they're multiplied together, and I raise that to a power. Let's take a look at 3x to the 4th. The product is 3x, and I'm going to raise that to the 4th, and that means that I'm going to do 3x times 3x times 3x times 3x. 1, 2, 3, 4. I have 4 of them. So let's just collect all the numbers together. So I have a 3 times 3 times 3 times 3. Commutative property says I'm allowed to rearrange the order when I multiply. So I'm going to do 3 times 3 times 3 times 3. I've got all my 3's. And now let's do the x's. And I have x times x times x times x. So I've got all the x's. Well, I have 4 3's all being multiplied together. That's the same thing as 3 to the 4th. I have 4 x's all being multiplied together. That's the same thing as x to the 4th. So look what happened. This exponent got applied to everything inside the parentheses. So as a shortcut, what you can do is you can take everything inside those parentheses and then apply the exponent to it. Let's do some problems. So first we have 5x cubed squared. So let's apply the 2 to everything inside the parentheses. So I'm going to get a 5 squared and an x cubed. Now apply that square, so I get an x cubed squared. 5 squared I know is 25. And then multiply your exponents, you get x to the 6th. Okay. Next one, 7m to the 9th cubed. Let's apply that exponent. So I'm going to get 7 cubed times m to the 9 cubed, which gives me 7 cubed times m to the 27. Now please don't leave it like this. Go ahead and figure out what 7 cubed is. And when you do that, you should get 343. So this is going to be 343 m to the 27. Okay, last one. This time we've got 3g to the 4th, all raised to the negative 2. Let's apply this exponent to everything inside. So I get 3 to the negative 2, g to the negative 8. Now I'm going to have to move these downstairs because they both have negative exponents. So when I do that, I get 3 squared, which is also 9. So I'm just going to write in 9. G to the 8th. And then because there's nothing left upstairs, put a 1 in there. Okay, so now we're going to simplify an expression with products. So I've got powers raised to powers, and I'm multiplying them together. First thing I want to do is multiply my exponents. So 1/2 times 10 gives me n to the 5. And then I have 4m n to the negative 2/3 cubed. I'm going to have to apply this cube to each one of these inside. So I get n to the 5th times 4 cubed times m cubed times n. Now this is where I'm going to multiply the negative 2/3 times 3, so I get n to the negative 2. And now take a look. I have n to the 5th and an n to the negative 2. They are being multiplied. So I can go ahead and just subtract those exponents. Sorry, add the exponents. So 5 added to a negative 2 gives me a 3. So my answer is going to be 4 cubed, m cubed, n cubed. Now please don't leave it this way. Take that 4 and cube it. And you're going to get 64 m cubed, n cubed. So there's my final answer. All right, example 11. This time I have x to the negative 2 squared. So I'm going to go ahead and apply this exponent to everything inside. So that's going to give me x to the negative 4 because I multiply my exponents together. And then I have 3xy to the 5th. Apply this 4 to everything in here. So I get a 3 to the 4th. Now apply it to the x to the 4th. Now apply it to the y to the 5th. This is where I multiply, so I get y to the 20. Look at, I have x to the negative 4 and x to the 4. That gives me x to the 0. And then I have 3 to the 4th, y to the 20. X to the 0, that just goes to 1. 3 to the 4th, go ahead and work that out. You should get 81. Y to the 20. And that's our answer. Okay, the last problem is a story problem we're going to raise a number in scientific notation to a power. So let's go ahead and read through our problem. The expression 1/2 mv squared gives the kinetic energy in joules of an object with a mass of m kilograms traveling at a speed of v meters per second. What is the kinetic energy of an experimental unmanned jet with a mass of 1.3 times 10 to the 3 kilograms, that's in scientific notation, traveling at a speed of about 3.1 times 10 to the 3 meters per second? That's also in scientific notation. Now they've given us the equation, so all you have to do is a plug-in. Kinetic energy equals 1/2 mv squared. Now in physics we say Ke for kinetic energy. Even though that's two different letters, it is one variable. So that's not K times E, this is Ke for kinetic energy. Okay, so let's plug in. It's going to be 1/2 times m, which is 1.3 times 10 to the third, times v squared, 3.1, times 10 to the 3 squared. Okay. Now we're going to use our rules of exponent to solve this. So I've got 1/2, and I have times 1.3, and this 2 gets applied to the 3.1 and the 10 to the 3, so I get 3.1 squared. So I've just collected all my numbers up front. Now I'm going to work on the exponents. I have a 10 to the 3 times, I have another 10 to the 3 that's been squared, so multiply those exponents, I get 10 to the 6. Now I'm going to grab my calculator and I'm going to multiply all these constants together up front. So 1/2 times 1.3 times 3.1 and square that 3.1. And I get 6.2465. And now I'm going to multiply 10 to the 3 times 10 to the 6. Add those exponents together, and I get times 10 to the 9. And this is our kinetic energy in joules. I'm going to go ahead and round this to 1 decimal place. And the reason is the numbers that I was given in the scientific notation, they're rounded to 1 decimal place. So my rounded answer is going to be 6.2 times 10 to the 9 joules. And that's it for today. Thank you for watching and have a great day.